Okay, problem number 2. Assume 5 pounds per second of fluid enters a steady state, steady flow system with P1, 100 psi absolute, density 1.2 pound mass per cubic feet, velocity 100 feet per second, internal energy at point 1, 800 BTU per pound mass, and live with P2, 20 psi absolute, density 2, 0.05 pound mass per cubic feet, V2, 500 feet per second, and U2, 780 BTU per pound mass. During passage through the open system, each pound rejects 10 BTU of heat. So find for the work in horsepower. So this is an open system. So let us write the given first. We have P1, 100 psi absolute, density at point 1, 0.2 pound mass per cubic feet. We have also velocity at point 1, 100 feet per second. We have internal energy. So this is specific internal energy. As you can see, it is per pound mass. BTU per pound mass. Small nga U. Then, for point 2, P2, we have 20 psi absolute. We have also density at point 2, 0.05 pound mass per cubic feet. We have V2, 500 feet per second, and U2, specific internal energy at point 2, 780 BTU per pound mass. We have each pound rejects 10 BTU of heat. Ano siya man siya? 10 BTU kay each pound man. So 10 BTU per pound mass. By the way, kanina is siya tuod. Na to siya nasuwat. Pounds per second, 5 pounds per second. What is that quantity, class? That is simply the mass flow rate. Diba ingon ko, ang mass nga na dot, that is called the mass flow rate. That is the mass per unit time. No? This is 5 pounds per second. No? Nasi per second. So this is 5. This is pound mass na siya, class, ha? Pounds per second. Another one is BTU of, so heat, not a heat. Pero ingon man siya, each pound man, so this is per unit mass. So negative because it rejects 10 BTU of heat per, again, per pound mass. Okay. So you are to find the work in horsepower unit. Okay, medyo taas na gini siya. Energy balance, since this is an open system, energy balance for an open system, we have heat is equal to delta P plus delta K plus delta EH plus work, stable. Work, therefore, is equal to heat minus delta P minus delta K minus delta H, or this is delta U minus delta EB. But sa ato ang problem, wala may indicate nga change in potential energy. So this is 0. Also, as you can see, ang ato ang kwan is in per unit mass, per pound mass siya. So kung ato ni siyang i-divide the whole equation by the unit, by the mass, so that this is work over the mass, Q over M minus delta K over M. So, i-divide na to itong whole equation since ang ato ang given is in terms of per pound mass man. Pero ato ra gihapon na siya i-cross multiply later on. Okay. So, let us, can you see a class? This is already given. So, there siya. Then what about kini? So, kini, pangitaon, this one also, and this. So, ang pinakadali kani sa itong unahon first, kay mas, murag mo siya si masayon kuhaon. Delta U plus over M. So, this is, kini siya nga nasa energy balance ng formula. This is capital letter U. So, this is the total internal energy. So, dividean na to siya sa mass. Muna ang that is now small u minus small u2 minus small u1. Kini siya specific internal energy. U2 is 800 minus 780. Saan ba kayo no? Minus radyo siya. So, delta U over M. So, nakuha na to siya dahil that is 20. Wala? U2 is bali wrong. No, na diha. Wrong dito. Okay. U2 is 780. Minus U1, 800. So, negative 20 BTU per pound mass. So, nakuha na po din na to. Kinisad siya na ana. So, arita ni delta K over M. Arita first ni kanisiya na to kuan. So, kanisiya class, asa man ni natukuhaon nga wala man siya mas ang kanipod volume wala sad siya. So, ato ang gamiton ng unsay available sa problem. Mass over volume, diba, is density. Right? So, mass over volume, si volume, ato na siya imbalhin dire. Mahimo na siyang delta P over density. Ano siya? Density. Kaya siya. So, kuha ko na to, this one. Delta P over density. Okay. So, let's continue. Kuha ko na to si delta P over density. So, this is now P2 over density 2 minus P1 over density 1. Atong P2 is 20 over density 1 is density 2, 0.05 minus then pressure at point 1, 100 over density at point 1, 0.2. Now, sa may unit ani? Ang unit na to sa pressure is PSI. So, pound force per square inch over the unit sa density, or pwede na to siya multiplyan sa reciprocal sa unit sa density. Okay, aron mag-multiply tayo instead of divided by the unit of the density, which is pound mass per cubic feet. So we will again multiply the reciprocal of the unit of density. So that is now cubic feet per pound mass. Okay, so that multiplyan na ni siya o 144 square inch in 1 square feet. So that square inch mo cancel, kaning square feet Kani makancel sa siya. Also, ang atuan ng unit is naka-fit din sa foot pound force per pound mass. So, kaning foot pound force class, we can now convert that. We have the conversion factor. 1 BTU is 778.16 foot pound force. So, kaning foot pound force, that is basically na a unit of nga atong gipangita work BTU. Kaning foot pound force class. But ato siyang i-convert to BTU. So, foot pound force. So that finally, ang ato ang unit now is BTU per pound mass. Okay, so mama na itong ipangita, no? Unit BTU per pound mass. So this is our delta P over density. The answer is negative 18.51. Okay, so finally, kuhaon na to si delta K over M. So, nakuha na po din nato. So, kanina lang ito kuhaon delta K over M. So, sa formula sa kinukuan glass sa kinetic energy, that is 1/2 mv squared. So, si M, gibalhin man na nato diri. So, ang atuan ng formula for delta K over M is 1/2 V2 squared minus V1 squared. Okay, so 1/2 V2 is 500 squared minus V1 squared, 100 squared. Ang unit sa V is feet per second. Unya kay squared man, so feet squared per second squared. But, unsa man nato, dapat maka-obtain tag unit nga BTU per pound mass. So, kini siya class di man ni mahimo, so maggamit jud ta ani og K. So, diri palang daan sa kinetic energy, that is 1/2 mass times velocity squared. Mass is in pound mass, then nato ang velocity is in feet per second squared. So, magamit ta og ubiran nato ni siya og 32.174, which is the value of K, pound mass feet per pound for second squared. So, si pound mass makancel. So, divide this one divided by the value of K. Okay? So, divide. Ito ni tarungon itong equal sign. Then, the equal symbol should be at the center of our equation. Divided by the value of K, 32.174 pound mass feet per pound for second squared. Feet per second squared cancel. We have now the unit. Isa ka feet din foot pound force per pound mass. So, ito siyang i-convert to BTU. 1 BTU is same 778.16 foot pound force. So, si foot pound force, matapad man na siya diri class. Ngayon na siyang i-rearrange. So, ang imuha na lang unit, finally, you have na the unit BTU per pound mass. Kini siya. Okay, so ayaw mo paglibog-palihog sa units. This is now BTU per pound mass. Calculate that you have now the answer 4.79. Okay. So, nakuha na nato tanan. Now, sa huwa nag-ingon ganina, kani siya, si work man may itong ipangita. So, kani, nakuha naman sa ninato. So, we will, all of this, para makuha nato ni si work, we will, kaning M dire, ato ni siyang i-transpose din ha, no? So, ato siyang i-cross, yeah. So that, dire, you have now the work, balhin na to si mass. So, dire si mass. So, M over, Q over M, minus delta K over M, minus delta U over M, minus delta P over density manasi. So, work now. Uy. Ang ato ang mass is kinisiya 5 pound mass per second. Pound mass per second. Q over M, nakuha ni na to. Si Q, ano, given man din siya, no? Negative 10. So, this is negative 10. Minus delta K over M, 4.79. Minus delta U over M, this is given. Negative 20. Minus negative 18.51. So, these units, ani nila matanan is BTU per pound mass. So, kung tanaw na to siya, BTU per pound mass. We have, this is BTU per pound mass. BTU per pound mass. Okay. BTU per pound mass. So, makakombine na ta since the same sila dami unit. But, since ang gipangita sa problem kay in horsepower man daw, kani siya nga pound mass, makancel man no? So, BTU per second. Convert na to ning second. 60 seconds is 1 minute. Seconds cancel. And, natay conversion factor. O, that is 41 horsepower is 42.2 BTU per minute. BTU is cancelled. Minute cancelled. So, ang unit no is in horsepower. So that you have now your work steady flow in 168.63 horsepower. That is now the final answer. Next, let us have the power of the pump. So, a pump is a machine used to add energy to a liquid in order to transfer it from one point to another point of higher energy level. So, that is basically a pump. Kita naman siguro taog pump, or I guess na naman siguro po the idea of what is a pump, no? So, I have to draw there. We have this illustration of a pump. Say this is your surface, and we have a pump here. With a pipe. Of course, we must have a pipe. So, mag-transfer man na siya of liquid. So, from lower level to a higher energy level daw. So at point 1, this is our suction line. And dire is our discharge line, point 2. Suppose this is our datum. So this would be the elevation sa discharge. And then this is the elevation of our suction line. Also, there is a suction line. We have the properties, velocity head is 2G, and the pressure head at the suction. And the discharge line also, we have the properties, the velocity head sa discharge, and also the pressure head at the discharge. So we have the what you call the total dynamic head, HP capital. It's equal to the delta Z. Again, this is the total dynamic head of the pump formula, V squared over 2G. So it's basically the difference in the elevation head plus the difference in the velocity head plus the difference in the pressure head of this system. So plus the head loss, total head loss. Again, concerning HP, HP here is not horsepower, but it is the total head or the total dynamic head. Dynamic head of the pump. So kanatanan imuha na siyang solvon to get the HP. This is since head man magisbutag head in meters or in feet ang unit. The static this is the elevation head delta Z. That is again elevation head. To get that is elevation sa discharge minus elevation sa suction. And then V squared, delta V squared over 2G. This is the velocity head. So it's basically the velocity at the discharge squared minus velocity at the suction squared over 2G. And then we also have the pressure head, delta P over rho G. Or rho G is gamma, diba? That is the pressure head. It's equal to the pressure sa discharge minus pressure sa suction over rho G. And lastly, we have the total head loss. It's the friction head. And so, can you see, this is the total dynamic head of the pump. But to get the power of the pump, we have this formula. Power of the pump formula. That is mass flow rate times the gravitational acceleration times the total dynamic head of the pump. So now, our unit is, mass flow rate is in kilogram per second. And we have the gravitational acceleration in meter per second squared. And this is in meters. Atong total head, kilogram meter per second squared is Newton. Newton meter is joules. Joules per second is, we have now the unit watts. No, watts. Or, from density. Density formula is mass over the volume. In terms of flow rate, so mass flow rate over the volume flow rate. Therefore, mass flow rate is equal to density times volume flow rate. So, kani siya nga mass flow rate, we can substitute that by the volume flow rate. Power of the pump now, we have another formula. Mass flow rate is substituted by density times the volume flow rate. times the gravitational acceleration, then times the total dynamic head of the pump. So this is now the formula for the power of the pump. So I guess this is the last one. Let us answer this sample problem. A hydraulic pump is handling 5 CFS, CFS of 60 degrees Fahrenheit water through an 8-inch inner diameter suction line and a 6-inch inner diameter discharge line. The suction gauge is on the pump center line and reads 10 inches of mercury vacuum. The discharge gauge is 20 feet above the center line. If the energy input to the water is 100 horsepower, find the reading of the discharge gauge. Okay, given. Tanan nga given, write down sa natin first. What is 5 CFS? CFS class is cubic feet per second, so meaning to say that is the volume flow rate. Flow rate, again, basta na ng word na flow rate, that is per unit time. So volume per unit time, that is why volume cubic feet per second. This is our volume flow rate, 5 cubic feet per second. Meaning to say this one is standard temperature here, 60 degrees Fahrenheit. Water, our liquid is water. So let's just write this down, 60 degrees Fahrenheit. We have inner diameter sa suction line. Diameter sa suction, 8 inches. 8 inches. Or that is in feet, that is 2/3 feet. Another thing also, we have the diameter at the discharge line, 6 inches inner diameter. So that is 1/2 feet. The elevation. The discharge is 20 feet above the center line. So 20 feet. While the suction gauge, sa suction is at the pump center line. So 0. Ano siya sa center line. Pressure. We are also given the pressure sa suction. 10 inches of mercury vacuum. When we say 10 inches of mercury vacuum, that is just equivalent to negative 10 inches of mercury. That is the gauge pressure at the suction. Can you see, by the way, let us convert this to a different unit of pressure nga, easily calculated. So PSI, convert na to siya to PSI, so 29.92 inches of mercury, that is the values of the atmospheric pressure, and PSI, that is 14.7 PSI, so that makancel nimo siya. So P sa suction now is 14.7 negative 4.91 PSI gauge. Also, we are given the power of the pump, 100 horsepower. So we are to find the reading at the discharge gauge, pressure sa discharge. Okay, we have the power of the pump formula. From the power of the pump formula, rho V volume flow rate times G times total dynamic head of the pump, and then the total dynamic head of the pump is also given by therefore makuha na to ang total dynamic of the pump, the power of the pump over density times volume flow rate times gravitational acceleration, or power of the pump over density times gravitational acceleration is gamma of the water times the volume flow rate. Okay, let us try to substitute. This is 100 horsepower. Hmm. 100 horsepower. So, kaning horsepower at 1 siyang i-convert class. We have 1 horsepower is 42 point, ilan man dyan insakto ano. Palimig naman po calculate. 42.4 or 42.2? 42.4 BTU per minute. Kaning BTU, ito po niya siya i-convert. 1 BTU is 778 foot-pound force. Anya ang minute, ito po niya siya i-convert. 1 minute is 60 seconds. Now, the gamma of water, 62.4. Gamma is pound force per cubic feet. Times the volume flow rate nga, 5 cubic feet per second. So, horsepower is cancelled, BTU is cancelled, minute is cancelled, seconds is cancelled, cubic feet is cancelled, pound force is cancelled. Wow! We have now the unit, the total dynamic head of the pump in feet. Okay. But dili man ni maya ito gipangita sa problem class. This is 176.21. Magaglayo pa ni siya sa kamatuoran. Okay. We will now use the formula sa total dynamic head of the pump. Ito yung formula sa HP. The total dynamic head of the pump is delta Z plus delta B squared over 2G plus delta P over rho G plus head loss. Wala may hatag na head loss, so this is 0. So, naatay value, nakuha na nato ang value ni total dynamic head, 176.21 feet. And so, kuha na to ni sila tag-sapod. We have ang pinakasayon, arita sa pinakasayon nga kuhaon, the delta Z of course. So, Z sa discharge minus Z sa suction. That is 20 minus 0, so that is 20 meters. Ay, feet, no? Feet. Okay, so nanataan niya. Kanya po na. Now, arita ni delta V squared over 2G. Asa man taan ni og velocity. So, actually, wala tayo given. Nama tayo given ng velocity? Wala. Arita ni continuity equations. Unsa man na si continuity equation? Continuity equation class states that for incompressible fluids, the volume flow rate is steady state. At steady state is constant in any section of the pipe, while for incompressible fluids, the mass flow rate is constant. So, kani by continuity equation. Let us just try to insert this one. N siya ha. N siya. Continuity equation. Ingon sa continuity equation, for incompressible fluids, the volume flow rate is equal. The volume flow rate at point 1 is equal to the volume flow rate at point 2. So that A1 area, the cross-sectional area is equal to the velocity. Times the velocity is equal to the cross-sectional area at point 2 times the velocity at point 2. So this is for incompressible fluids. Now, for compressible fluids po, ang iyahang mass flow rate maoy equal between the section sa pipe. So, we have density at point 1 times the, this is the cross-sectional area at point 1 times the velocity at point 1 is equal to the density at point 2, cross-sectional area at point 2, and the velocity at point 2. So, kanisiya again, this is for compressible fluids. This is by continuity equation, kanisiya principle. So you can see, for compressible fluids, for incompressible fluids, ang density is just the same. So ang density at point 1 and density at point 2 is same. So ma-cancel. So na nga ma-reduce ang formula niya for incompressible fluids to area. So ang atong area, tangali in meters squared. Then our velocity in meters per second. So we have the unit for the volume flow rate, m cubed, cubic meter per second. No? So, volume flow rate equal between the 2 points along the pipe, while for incompressible fluids, ang equal niya is the mass flow rate. Okay, so using this concept, we have the volume flow rate is equal to A1 V1 equal to A2 V2. By the way, kanin siya nga A class, this is the cross-sectional area. Dito mag V2. Arita sa discharge o suction na to ang gamiton. Okay. So, suction niya discharge. So that, kanin siya, diba this is equal to, this is V sa discharge squared minus V sa suction squared over 2G. So, kani, makuha na to si VD o si VS using this relation by continuity equation. So, let us have first VD. So, VD is equal to the volume flow rate over cross-sectional area sa discharge. Okay. So, we have 5 cubic feet per second over cross-sectional area pi d squared over 4. Pi diameter sa discharge is 1/2. 1/2 squared. This is in the unit feet squared. So, feet cube niya, feet squared. So, makuha kag unit nga feet per second. 25.46 feet per second. While VS is volume flow rate. Dara si VS. Volume flow rate over area sa suction. Area sa suction. So, volume flow rate is 5 cubic feet per second over area sa suction, pi d squared over 4, d sa suction, diameter sa suction, 2/3 squared. This is feet squared, cubic feet, feet squared, naka-unit nga feet per second. This is 14.32 feet per second. So that, kani siya, substitute nato na nga formula. This is na V delta V squared over 2G is equal to VD 25 0.46 squared minus 14.32 squared over 2g. 2 times 32.174. This is feet per second, feet squared per second squared. 32.174 feet per second squared. So, feet per second squared cancel. So, ay muha na unit is in feet. 6.89 feet. Okay. Kapit na. We have napaday si P. So, kanina solve na rin na to si delta P over rho G. Delta P over rho G is just equal to P pressure sa discharge over rho G minus pressure sa suction over rho G. Pressure sa suction over rho G, masolve man ni nato, no? This one. PS over rho G is equal to rho G is gamma of water. So, pressure sa suction, negative 4 point, dera, kanisya plus pressure sa suction, negative 4.91 psi. 4.91 psi is pound force per square inch over gamma of water, 62.4 pound force per cubic feet. So, para makancel na, we have 144 square inch per cubic square feet. So, square inch cancel. This is also cancel. So, nakaisa ka feet na unit, which is matransfer na lang. So, this is now negative 11.33 feet. And so, from ari atong continuation. From the formula sa HP, gikan to din na is equal to delta Z plus delta V squared over 2G plus pressure sa discharge over rho G minus pressure sa suction over rho G plus head loss, which is 0. Now, kani matong i-isolate kani siya. So, CP pressure sa discharge over rho G now is equal to HP, which is nasolve na nato 176.21 minus delta Z minus 20 minus V squared over 2G 6.89 minus 6.89 plus PS over rho G kani siya plus negative 11.33. Okay, so the answer now for PD over rho G is equal to 137.99 feet. Now, we will cross the rho G or the gamma of water. 137.99 feet. The gamma of water is 62.4 pound force per cubic feet. So, feet cancel. We will convert it to pressure man, pound force per, so himuha na to siyang PSI. First, we have 1 cubic foot. square foot is 144 square inch. So, ang square ani, feet, makancel. So, naka-unit nga pound force per square inch. Pound force per square inch, PSIG. PD. Is now 59. Palihog po calculate class of na, sakto ba nyo siya? 0.8 PSIG. So, nga to, pag yun siya i-convert further, since ang given sa pressure sa suction is in inches of mercury. So, let us also convert this to inches of mercury. This is 14.7 PSI. Inches of mercury, 29.92 inches of mercury. So, pressure sa discharge now is 121.7 inches of mercury gauge. Tanaw na to. Okay. This is now your final answer. Okay, dako siya pressure sa discharge. Ang pressure sa suction class is just, of course, it's vacuum pressure, negative 4.91 psi. Then sa discharge, dako kusog pressure no, 121.7 inches of mercury. Sa suction is 10 inches of mercury vacuum. And this one, 121.7 inches of mercury gauge. Okay, so I guess that is all. Thank you all for listening.